So why is the image distance for lens A longer than for lens B? So why is this image distance, that distance there, longer for image A, for lens A than for lens B? And the reason is light refracts a lot more. Why does it reflect a lot more? Because lens B is a lot thicker, or you could say it's more powerful. So any one of these three statements below would give you a mark. The following question gives you a table where you've got the object distance is increasing from the lens. So this distance, so the object is being placed further and further away from the lens. So that distance is increasing, and we are getting an image that is produced, and its magnification is getting larger and larger. Okay, so the magnification, so the image is getting twice as big, 3 times as big, 4 times as big, 5 times as big. The question asks for the relationship between the image distance and the magnification. This data shows the relationship between object distance and magnification. So we must go back to the graph and make the link between image distance and object distance first. So we can pick any one of the lenses. It follows the same pattern. As the object distance increases, the image distance also increases. So we know that as object distance increases, the image distance increases, and the magnification also increases as a result. So the first statement, link object distance and image distance. So object distance increases, the image distance increases, and then as the image distance increases, the magnification increases. The next part gives you a key piece of information, and it says that this lens C has a shorter focal length. So this distance, this focal length, it's much closer to the lens. That means that the rays of light, when they come in parallel, bend in at a much closer distance to the lens. For that to happen, that indicates, that's the steeper angle, that indicates more refraction is taking place. And because more refraction is taking place, that means it must be going through more glass. Therefore, the lens must be thicker. Question 4, we are looking at seismic waves. P waves are longitudinal, S waves are transverse. The next question, we have got an envelope. Within this wave envelope of a P wave, we've got 1, 2, 3, 4 waves passing in 10 seconds. So frequency is the number of waves passing in 1 second. So it's 4 waves divided by 10 seconds, and it's 0.4 waves are passing every second. So it's 1 mark for the answer of 0.4. If you get this wrong, and the next part of the question where you perform a calculation is a correct technique, you will pick up the marks. The formula that links wave speed, frequency, and wavelength is wave speed equals frequency times wavelength. You could have rearranged it and written it as frequency equals wave speed divided by wavelength, or wavelength equals wave speed over frequency. Calculating the wavelength, so first we have to rearrange the equation. So it's wave speed over frequency equals wavelength. The wave speed is given us to us is 7,200. The frequency we have worked out in the previous question. If you put the correct frequency, the incorrect frequency here from your previous question, you will still pick up the marks. So you'll pick up 1 mark for the division and 1 mark for your incorrect answer, but you will not pick up the third one. So you will still pick up 2 marks there. So it's 1 mark, 2 marks, 3 marks, 1 mark, 2 marks, 3 marks, and 2 marks if you've put this as an incorrect value. So explain why the study of seismic waves provides evidence for the structure of the Earth's core. Here we have P waves passing straight through the Earth and detected on the opposite side of the Earth, whereas S waves are blocked off. This indicates that S waves must have encountered some sort of density change for them to be blocked off, indicating that there's a core that exists in the center. Also, there is a shadow region on certain sides of the Earth where there are no S waves and no P waves, and the only explanation there is that there must have been a density change as the waves are passing through towards the Earth's core. And that will pick you up 2 marks, one for mentioning the shadow region and one for mentioning that P waves get to the other side and S waves don't. Question 5, we have got a ray diagram. It is 4 marks in total. The accuracy of this diagram will give you 1 mark. Another mark is for this ray coming in and bending in towards the focal point. The third mark is ray that's going towards the center of the lens and passing through. And the fourth mark is producing this inverted arrow here representing the image, and the accuracy of this drawing here, this entire drawing, that being 4 squares approximately in size, that will pick you up that last mark. What type of image is this? These rays cross to produce an image on a screen if it was placed here. This is a real image. It is inverted, it's upside down, and it's smaller than the actual object, so it's diminished. Any one of these 3 gives a mark. Here we have got a practical, a refraction practical. You've got light passing through a glass block and it refracting, and here are some measurements. The question is, how could a student have taken these measurements? Now, this is a core prac, part of the syllabus. You should have done this in class. And the second point that you must include in your answer is what could have been a source of inaccuracy as well. So this is 6 marks in total. I've not written anything here, but here is the mark scheme, and you can see the reason why I haven't written anything here. There are so many different possible marking points that I'll go through each one. So tracing the glass block on a piece of paper, then removing the glass block, drawing the normal, drawing the incident ray, measuring the angle of the incident ray, moving the glass block out of the way or putting the glass block back, marking where the ray exits the glass block, drawing a line representing that ray, removing the glass block, connecting the incoming incident angle to the outgoing ray. That will give you your refracted ray, and then measure the angle of refraction using the protractor, and then repeating these results for all the others. That's possible 10 marking points that you could have got. And the next 2 for the possible source of accuracy, commenting on the ray that comes out of the ray box is not a fine ray. It's not pencil thin. It's quite thick. So it will be difficult to pinpoint exactly where the center of that ray is with a pencil. So that is source of inaccuracy. So you could have picked up 5 marks from here, possible 5 maximum mark there, and a possible 1 maximum mark there, and as a result you could have picked up your 6 marks.